Betelgeuse, the glowing red star perched on the shoulder of Orion the Hunter, has long captivated stargazers with its imposing presence in the night sky. Recently, however, this celestial giant has drawn even more attention due to its unusual and unexpected behavior. Astronomers and space enthusiasts alike are abuzz with anticipation over the possibility of witnessing something extraordinary, a supernova explosion that could outshine the moon and be visible even during the day. While the exact timing remains elusive, experts speculate that this cosmic event may unfold in the not-so-distant future. Although you may not know it by name, Betelgeuse is likely a familiar sight to many. Its reddish hue and brilliant shine make it one of the most recognizable stars in the sky, especially during winter months in the northern hemisphere. If Betelgeuse were placed at the center of our solar system, its massive girth would extend past the orbit of Mars. It is a truly colossal red supergiant, hundreds of times larger than the Sun, and its unique properties have long made it a subject of fascination and scientific inquiry. What makes Betelgeuse especially intriguing is its classification as a semi-regular variable star. This means that its brightness fluctuates over time, sometimes significantly, due to changes in its internal structure and outer layers. These changes are thought to be precursors to the star's ultimate fate, a cataclysmic supernova explosion. In recent years, these fluctuations have become more unpredictable and pronounced, particularly during the mysterious event known as the Great Dimming, which occurred between late 2019 and early 2020. During the Great Dimming, Betelgeuse's brightness dropped to levels never before recorded. For a star usually ranked among the top 10 brightest in the night sky, this was an extraordinary development that sparked intense speculation. Was this the beginning of its death throes? While scientists have since concluded that the dimming was likely caused by a massive ejection of stellar material that partially obscured the star's light, the incident underscored how little we truly understand about the final phases of a red supergiant's life. Following the dimming event, Betelgeuse's behavior has remained unusual. In some cases, its brightness has increased dramatically, by more than 50%. On May 20, 2023, a Twitter account known as Betelbot, which tracks the star using data from the American Association of Variable Star Observers, reported a remarkable 142% increase in brightness. This sudden surge vaulted Betelgeuse to the position of the seventh brightest star in the night sky, up from its typical spot at number 10. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics noted this unprecedented shift with great interest, highlighting how Betelgeuse continues to defy expectations. The star remains easily visible from both hemispheres, especially during the dusk hours in the southern skies. In the northern hemisphere, it becomes more prominent as the days grow shorter. Its visibility, combined with its irregular behavior, has made Betelgeuse a favorite target for both amateur and professional astronomers. The fascination with this red supergiant isn't just about its brightness, but what it represents, a rare opportunity to observe the final evolutionary stages of a massive star in real time. Astronomers are particularly excited about the potential to study these late-life processes up close. Typically, by the time a star explodes in a supernova, we are left only with remnants, neutron stars, black holes, or supernova remnants scattered across space. But Betelgeuse, located a mere 650 light-years away, gives us a front-row seat to stellar death in slow motion. That closeness allows scientists to monitor changes in luminosity, temperature, and other variables in a way that has never been possible before. Some speculate that when Betelgeuse finally does go supernova, it could be visible even during the day for a full week and may be bright enough to cast shadows at night. Such an event would be a once-in-a-lifetime spectacle for humanity. But the question remains, when will it happen? According to current understanding, Betelgeuse is still in the earlier stages of nuclear fusion involving helium, meaning that it has not yet begun the final fusion processes that lead directly to a supernova. Inside red giants like Betelgeuse, fusion occurs in a sequence, first hydrogen, then helium, and eventually heavier elements like carbon, oxygen, silicon, and finally iron. Once iron accumulates in the core, fusion can no longer sustain the star, and it collapses under its own gravity, triggering a massive explosion. At present, analysis of Betelgeuse's atmospheric chemistry suggests it is still fusing helium into carbon, a stage that precedes the end by a significant margin. This means that while the star is certainly on the path to destruction, we may still be centuries, decades, or even millennia away from witnessing the final moment. Scientists like Heidi Morris of the Los Alamos National Laboratory emphasize that although excitement is high, patience is necessary. Betelgeuse has changed significantly since the Great Dimming, displaying new patterns in brightness and radial velocity that continue to baffle researchers. One particularly interesting discovery is that the star's brightness cycle, which traditionally spans about 400 days, has shortened to around 130 days. This suggests that something fundamental has shifted in the star's internal dynamics. Astronomer Andrea Dupree, who has long studied Betelgeuse, attributes these changes to the star's expulsion of a portion of its outer atmosphere during the 2019 dimming event. The forceful ejection created a cloud of dust and gas that likely blocked our view of the star, giving rise to its dim appearance during that time. These ejections are not typical for Betelgeuse and represent yet another layer of mystery. They also reinforce the idea that the star is approaching the end of its life, even if we cannot pinpoint exactly when that end will arrive. In a paper co-authored by Dupree and researchers from Harvard and UC Berkeley, it was estimated that Betelgeuse may take another 5 to 10 years to return to its pre-dimming brightness cycle, if it ever does. The paper states that since the Great Dimming, Betelgeuse has not returned to its former behavior, which could signal a more profound internal change within the star. Despite all these findings, the greatest challenge remains prediction. Peter Groover, an astronomy professor at the University of Portsmouth and a supernova expert, cautions against overconfidence. He notes that the astronomical community currently lacks the tools to accurately forecast when any star, even one as well studied as Betelgeuse, will explode. Throughout recorded history, there have been very few observed supernovae, limiting our ability to draw solid conclusions. This scarcity of data makes it extremely difficult to model the end-of-life timeline for stars, and Betelgeuse, for all its brightness and size, still holds onto its secrets. It is easy to understand the public's fascination. The prospect of witnessing a supernova, a cosmic explosion so intense it can rival the brightness of the entire galaxy, is incredibly compelling. And while we know it will happen eventually, the lack of certainty only adds to the drama. Some scientists believe the explosion might occur within our lifetime, while others are more cautious, suggesting it could be thousands of years away. The star's erratic behavior over the past few years certainly stirs excitement, but it also serves as a humbling reminder of how much we have yet to learn about the universe. Until that inevitable moment arrives, Betelgeuse will continue to inspire awe and curiosity. As we gaze up at Orion's shoulder and see that reddish light glowing in the dark sky, we are reminded that we are watching a ticking time bomb, albeit one whose countdown remains hidden. It may explode tomorrow or in the distant future, but when it does, it will be one of the most spectacular events humankind has ever witnessed. And in that flash of light across the heavens, we will be watching not only the end of a star, but the continuation of a cosmic cycle that has shaped the universe for billions of years. As Betelgeuse continues its unpredictable journey toward its inevitable end, astronomers across the globe remain vigilant, monitoring every nuance of its behavior with ever-improving technology. Ground-based observatories, space telescopes, and even amateur astronomers are all contributing valuable observations to a global effort aimed at understanding this colossal star's fate. Instruments such as the Hubble Space Telescope and the Atacama Large Millimeter Submillimeter Array, ALMA, have provided detailed imagery and spectral data, helping scientists to peer into the outer layers of Betelgeuse and detect changes in temperature, mass loss, and motion. These advancements in observation are providing insights not just into Betelgeuse, but into the life cycle of massive stars in general. Studying Betelgeuse offers a kind of blueprint for what other red supergiants might experience as they near the end of their lives. These insights could help astronomers predict and understand future supernovae elsewhere in our galaxy or even beyond. Moreover, the possibility that the Betelgeuse supernova might already have occurred, and we are simply waiting for its light to reach us,